Have you ever thought about how the Earth ended up with such a variety of species on the planet? You're probably thinking about the arthropods, mollusks, and brachiopods, among the other phyla we researched in our last project. Much of our understanding about the origin of this diversity comes from animals evolving the ability to mineralize parts of their body, essentially leaving behind hard parts which have a higher likelihood of becoming fossilized. Paleontologists have been studying fossils for a long time, but 1909 marked an important year for the field when the Burgess Shale was discovered. This fossil bed, which dated back to the Cambrian period, was revolutionary for the field. It is a wealth of fossils from many different phyla and is generally considered to be evidence of the Cambrian explosion. Paleontologists before this discovery knew a lot about trilobites and other species that were very abundant and had fossilized hard parts. The Burgess Shale, however, added much new information on these already developed fossil types, as well as opening many new pathways and understanding about animals that did not have mineralized body parts because of its outstanding preservation. This Conservat Lagerstätten, or exceptionally preserved fossil storage place, was long thought to be a unique window to the past until Professor Howe's discovery of the Chengjiang fossil bed in 1984. Both Chengjiang and the Burgess Shale are so important for the field because of their detailed preservation of soft-bodied creatures. The Chengjiang fossils found in this shale really provides a new look at the explosion of life 530 million years ago, during the early Cambrian. It brings to light other successful animals during this period that were not just trilobites, and it preserves delicate, soft animals that would usually never make it this far through geologic time. A key feature of the Chengjiang Shale is its documentation of life's early stages in the lower Cambrian. This window to the past is one of the earliest records of the Phanerozoic eon. The fossils from this site occurred exclusively in the Wanshan member, the younger of the two members in the Helinpo Formation. Looking more closely at this timescale, the Xian-2 member is represented by gray to black siltstone. Above that, the Yan-Shan member consists of gray to greenish gray, finely bedded mudstone with silty and sandy interbeds within the layer. The fossil-bearing Lagerstätten layer is actually 100 to 150 meters tall, according to the Cambrian fossils of Xinjiang, China, and academic papers the authors looked at. This seems hard to believe that there is a 49-story layer of fossils, but here's a picture for reference with the rolling hills landscape in the background. In addition, here is Professor Xiang-Guang standing in front of the Xinjiang Shale, where he discovered the first soft body fossils of the area. As you can see, many fossils here are actually found manually splitting the rock with pickaxes and looking carefully for the thin fossil images preserved in the shale layers. An important question of this site, though, is how it was able to preserve the fossils so well. To understand this, we need to look into the geologic history of the site in the eastern Yunnan province of China. The Xinjiang Lagerstätte was not always in the same place as it is today, and the Cambrian geologic setting was very different. During the early and mid-Cambrian times when the shale was being deposited, the South China Plate was at a low latitude on the ancient Gondwana supercontinent. The fauna of this area shows similarities to the Burgess Shale from North America due to the similar latitudes and time of deposition, but they still exhibit important differences, being separated by the Paleo-Ocean. The shallow marine environment of this area make up the depositional environment of the Helinpu Formation, where these fossils are found. The strata becomes more coarse-grained moving up the member, and this is attributed to a prograding delta approaching the region where the mudstones were deposited, around here. The Yanshan member from the Helinpu Formation was a sedimentary basin that was deposited over tens of thousands of kilometers, and even left fossils in this member found in other areas of China. While discoveries from the other locations were important in establishing the origin of vertebrates, the Xinjiang Shale is known for its preservation of soft body fossils. This worm is in the process of digesting a meal, is an example of a soft body fossil found there. Other fossils include phyla from Porifera, Cnidaria, Ctenophora, Nematomorpha, Priapulida, Hyolitha, Lobopodia, this is Lobopodia, and Arthropoda, and Brachiopoda, among others. The Xinjiang fossil site is open to the public, but it is entirely owned by the Chinese government and is protected as a national geopark. This means that industrial development and other human impacts are strictly regulated. Visitors to the area range from 5,000 to 20,000 people every year. The protection of this site is an ongoing job, but it is being taken care of for future paleontologists. Who knows where the next Conservat Lagerstätten will be discovered?